Tutorial, we are going to demonstrate our system ShiftScope, which recommends visualizations based on users' dynamic data focus. So ShiftScope is designed to help users perform exploratory data analysis, which is a complex process as users may not know what information to explore and what data part to explore. So they have to go through the cycle of generating hypotheses, locating information, doing sense making, and based on what they have learned from the data, they change their focus on different data areas. Let's look at a quick example that illustrates the scenario where ShiftScope benefits from explicitly modeling users' data focus. So Alice and Bob have the same interactions at time step t, t+1 and t+2, while exploring the wildlife strikes dataset from Federal Aviation. But the data focus changes at the subsequent interaction. While Alice wants to analyze the cost of aircraft carriers being hit at different stages of flight, Bob is more concerned about the safety of wildlife survival and wants to explore which wildlife species faces danger. Existing approaches based on pre-trained models to suggest visualizations will fail as users' data focus is changing despite having the same history. We formalize EDA using a dual agent markup decision process framework. The user agent lets the RL-based recommendation agent know about potential shifts in users' data focus. In addition to this information, the recommendation agent uses expletive user feedback on past recommendations to recommend 6 visualizations. Both agents collaborate so that one can accurately model the data shifts. ShiftScope displays the data focus simulations for the user as a visualization recommendation. Let's look at the demo for our system. To start, the user can decide to import any dataset. You can choose a file. We support JSON and CSV file formats. For example, we import the movies dataset. And other JSON formats we support is like this, where this shows car state.json dataset. Okay, now that after we import the dataset, we have this data view that shows the data attributes: title, US gross, worldwide gross, and so on. Users can scroll on this data view to get more detailed view of their dataset. Also, we have the attribute color encodings that match the data view. This is the chart editor where the user can edit the chart, and the system automatically recommends relevant visualizations for this specific dataset. This comes from statistical properties in the dataset. In the chart editor, the user can choose X, Y, color, size, and other encodings. They can use this drop-down that already populates with available data attributes. Rather than doing that, the user may want to click on the already generated visualizations. Now there's no manual chart editing. They can start with this template as the baseline. Now the user can decide to change this template. They might want to know about, since it's a movies dataset, they might want to know about US gross and different ratings for these different movies. Let's do IMDb ratings. Maybe the user wants to do try different colors, get colorful graphs. After changing that, it automatically populates the Vega Lite specification for this chart, and the chart is rendered in the center screen. The user can click on similar charts to get recommendations. As you can see, at the top of suggested charts, we see the recommendations relevant to user's current chart. For example, here we see Rotten Tomatoes rating, and here we see IMDb ratings, close associate of IMDb ratings. We also see US gross between both charts, and we also see worldwide gross in the second chart. Further, the data encodings are also different. The chart user created, it's not that great, but our recommendations portray the same information in a much more meaningful way. After the user finds something interesting, they can bookmark those charts and come back to them again for a new analysis.